Here's another example of a molecule, actually an anion, because it has a negative charge, where you have to add more electrons than an octet to the central atom. And here we know the central atom that's going to get its octet expanded is sulfur, because sulfur is in period 3 of the periodic table or below. So I've already counted the number of valence electrons. I've done step 1 of finding the Lewis dot structure. And remember, it's an anion, so if it has a negative charge, we have to add 1 electron. So hopefully y'all can do that already. Just make sure you can, make sure you agree with me here. And I'm going to go ahead and start making our Lewis dot structure by attaching all the fluorines to the central sulfur. And we already have expanded the octet of sulfur. We might have to expand it even more. Let's see. So now we want to give everything an octet. So I'm putting these little electron pairs on all the fluorines. And let's count the number of electrons. So pause the video and see if you count what I count. I'm getting a total of 40. 30 in the lone pairs, like these little guys, and 10 in these bonds here. So we have 40 in our Lewis dot structure, but we need 42. We have to add 2. Usually, the first Lewis dot structures we saw, we had to get rid of some. Here we have to add some, and we just put them on the central atom. So the presence of this lone pair here is going to affect the geometry by pushing these fluorines away. Well, we can also write this electron pair as a kind of a bubble with a lone pair written in it. So now we have our full 42 electrons in our Lewis dot structure, and the way for all of these areas of electron density, by which I mean either the atoms, the fluorines, or the electron pairs, the way for these areas of electron density to be as far away from each other as possible is for them all to be at 90-degree angles. And this is a lot like octahedral geometry, except one of the atoms isn't going to be an atom, but instead it's just going to be 2 electrons. So what we have here is actually a square pyramidal geometry if you're just looking at where the fluorine atoms are. And let me show you that in Avogadro.